given a grid where Cij represents dot represents white and hash represents black. So what we need to do is that we need to perform these operations that while the topmost row is entirely white, that is, it has only dots there, then we remove the topmost row. If the bottommost row is entirely white, we remove it. Similarly for left and rightmost rows, rightmost columns, if they are entirely white, we need to remove those rows and columns. So what we need to do here is we need to track which is the first row from top which has a hash in it, because it's given that we need to remove the rows which have entirely dots in it. So the problem summarizes to tracking the topmost row having a hash, bottommost row, like starting from bottom, the first row that is having a hash, starting from left, the first column that is having a hash, starting from right, the first column that is having a hash. So we just need to initialize 4 variables, and then we need to traverse through the grid and see which is the row or column that is having a hash. Like here, as you can see, the topmost row is entirely white, bottommost is also white, this leftmost is white, and rightmost is white. So we just need to remove those 4 rows and columns and we get the answer. So let's see what the solution is about. It's all about implementation. See, we have the height and width from the user and we have the grid. So while top is less than height, we are checking if every single element of the row is dot or not. If we get at least one hash in that, we initialize f to 1, that is we have found one hash, and then we break it. And if we have found the like hash in that particular row, we break through our outer loop also, or else we do top plus plus. Similarly for bottom, we start from h minus 1 and from right w minus 1 and left from 0. The approach is very similar, just you need to traverse for those 4 vertices directions. And then finally, you need to print the grid from I equals to top to bottom and j equals to left to right. This is all about problem number 2. Now moving on to the third problem. Is this clear? Hello. Okay. Moving on to the third problem. Were you able to solve this problem? Arnav?
No, Didi.
Okay, okay. So can you tell me like what was your approach? Like could you think something?
I guess I spent too much time on the previous question. I wasn't much focused on this one.
Okay, okay. So the previous question is clear, right?
Yes, yes.
Okay. So in this problem, you see there are we have some birds which are colored from 1 to n, and we have a day d such that the a particular bird changes its color at the dth day from ai to bi. So what does that mean? That before di, that is still di minus 1, the bird has a color ai, and from and after di, the bird is having a color bi. So we need to calculate the number of distinct colors at a particular day. Now we need to print the number of distinct colors for all the days starting from 1 to n. Now the extreme brute force that you can think of is like for each and every day you traverse through your birds array and you just calculate what are the colors you have and calculate the number of distinct colors. This is the extreme brute force that you can think of. Now this approach will give you a time complexity of big of n into m. But you see here the constraints are pretty high. Big of n into m will cost you like 9 into 10 to the power 10, which is far greater than 10 to the power 8 operations. Right. So we need to optimize that. So what we need to track is that how many birds are changing its color at a particular day. Because you see, the birds are not changing color at multiple times. They're just doing that at a single day. Like before that day, they are having another color, and after or from that day, they are having another color. So if we track initially what are the frequencies initially of the colors that we have, and then for each day we just deal with the new frequency, new color frequency, and the old color frequency, we will get our result. Because you see, when we are calculating for suppose the sixth day, we need not consider the previous birds were I mean the previous the birds were changing their color on previous days, because we have already calculated up to the fifth day. So when we are calculating for the sixth day, we just need to consider those birds which are changing its color on that particular day only. Suppose, let me take an example. um, just a second. Suppose at a day 6, one bird is changing its color from 3 to 4, and another bird is changing its color from, let's say, 6 to 8. Okay, at day 6. Now, before that, suppose we have some frequencies already present in our array. Suppose before that the frequency of 3 was equals to 1, uh, frequency of 4 was equals to 2, 6 was equals to 2, and there was no 8. Okay. Now, when we get a particular day, what we need to do is that we need to track that what changes a particular bird is going through. So, a bird is changing from color 3 to color 4. So, the frequency of color 3 should reduce by 1, and the frequency of color 4 should increase by 1. Now, how to calculate the number of distinct colors? So, initially, if I already had the number of distinct colors for day 5, okay, because we are doing that for each and every day. So when we are calculating for day 2, I already have for day 1. When we are calculating for day 3, we already have the previous distinct values. So when we are calculating for day 6, I already have the number of distinct colors at day 5. Now, what are the changes at day 6? Just these two changes. Now, the frequency of what happened? Just a second. Just hold on a second. Okay, so while it's loading, let me tell you that, yeah, you just need to increment the frequency of the new color, and you need to decrement the frequency of your old color. So if the frequency, while decrementing the frequency of the new color, if it happens like, just a second. Yeah. I'm facing some problems. So let me just tell you verbally only. So while you are decrementing the frequency of your old color, if the frequency becomes 0, then we are losing a color, because previously we had some distinct colors. Suppose we had 5 distinct colors. Now we are decrementing the frequency of 3, and the frequency of 3 becomes 0. That is, we are losing the color 3. So we need to do distinct color minus minus. All right. Now, when we are adding a new color, if this color is already present in our array, that is already present in our distinct colors, which we have taken before. we need not increment our distinct colors because we are not getting any new color. We are just incrementing the frequency of whatever existing color we had. Okay, but if the new color is not present in our array, suppose like the example that I gave, 8 was having a frequency 0 before. So on the sixth day, if we are getting a new color that is 8, so we need to make distinct color plus plus. So what we need to do is that from summarizing the whole problem, that for each day we need to track what are the birds that are changing color and what colors they are changing. For each day we need to track that. Okay, so you just take a 2D array, and for each day you see what are the birds that are changing the color, and you push a pair into that particular index of that 2D vector. Okay, like at row 6 it will be pushing 3 comma 4 and 6 comma 8, the example that we took. These two birds are changing this colors in the sixth day. So what you need to do is that then you traverse through the days. We are we need to print from 1 to m, so we traverse through 1 to m, and we just take the mth row from that vector. Mth row, I mean the first row, second row, third row, like this. You just take that row, extract all the pairs that you have, and then calculate these things like the frequency of old color minus minus. If it becomes 0, then we are losing a color, so distinct colors will decrease by 1. And if the new color is the frequency of the new color is 0, that means we are getting a completely new color which is not present before, so our distinct colors will be plus plus. And finally we'll just increment our new colors frequency. This is what it is. But there's a special case for day equals to 1. As you can see, let me show you the solution because the board is not working properly. Um, See, for day equals to 1, we are just doing frequency of b plus plus, because for day equals to 1, it's given in the question that you consider from day 1 only the bird is having the frequency b, and the bird is not changing any further color, so we don't need to push that into our this events 2D vector. Fine. Now see, we are initializing the frequency array, and whatever colors we had initially, we are just incrementing that. And then we are pushing the vector that we are pushing the changes, that is the old color and the new color, in our events 2D vector. Now initially we are calculating the number of distinct colors for day 1. Okay, so what are the elements that we have in our frequency map which has a frequency greater than 0? Those are the distinct colors that I have in day 1. So this dist is containing the number of distinct colors of day 1. We are just printing that. Then we are traversing from day 2 to m because we need to print for all the days. And for each of the days, we are extracting the pairs of that particular row of the 2D vector. Okay. Then, as I have said, we are doing the frequency of old color minus minus. If it's becomes 0, distinct color minus minus. And if the new color was not present, just plus plus, then the frequency of the new color becomes plus plus. And finally, I print the number of distinct characters, distinct colors in a particular day. So this was the approach for problem number C. Do you have any doubt? If you're
No,
unable to answer, huh?
no doubts.
Okay, okay. Sorry for the disturbance. So, uh, Sarthak will be taking the next question. Thank you.
Okay, so I'll be sharing my screen now. Uh, so let's move on to the next question. Okay, so in this question, I'm assuming you've already read the question, so I'll just be giving the gist of the question. So basically, what we need to do is that in this question, you need to maximize the profit or the value as it is said in the question. So what you need to do is that all the strings, all the characters in the strings have certain x and y attached with them. So whenever you can swap the character at any position, like you can make an S an R or you can make a rain an S. So while swapping, if you swap any of the characters, then you would have to decrement it by this x value given here. But there is a catch here, that suppose an R is followed by an S, like in this scenario. If that happens, then you can just add the value of R here. Like here the value is 3, right? Like it's one lesser than this. So R and S. So here you can just add 3 because R is followed by S. So basically you need to maximize the profit. So like it's a pretty simple DP problem. As you guys might have understood that the greedy solution won't be working here because okay, so suppose, okay, so there might be a scenario where we are given an S and R, and uh whatever, like whatever be the value of x, and let here be a value y. So it might be the scenario that you change both of them, like you make it R and you make it S. And in this case, what will happen is that you would have to decrement x 2 times, like minus x, but you can also add one y here. So all you need to do is to ensure that the value that you're getting at the end is maximum. Or it might also be possible that you don't need to flip both of the values. Like it's already given an s and r, and like if suppose this becomes negative, so it's not useful doing it. But the thing is that all of the values are interdependent. If you make this r and s, then the values before it would also be affected by it, right? So in this, like it's pretty simple to think of a DP state here. Like we can just take a DP state, whatever. Like let's not call it X, let's just call it I, and this can be 0 or 1. So what would happen here is that uh, till ith index, what is the maximum profit that I can make if my current value, like let's if it's 0, then we're talking about, if it's 0, then we're talking about the sunny state. If it's 1, then we are talking about the rainy state. So what we'll do is that at every position we'll try to uh, replicate the possibility that it can be an S and an R, and whatever the maximum value can be achieved, keeping in mind that the previous index that we have got. Like the thing is that since R has to be followed by an S for Y to give us a profit, right? So the thing here is that okay, the y is this. So the r needs to be followed by f for y to give us a profit. So we don't care about what happens after this or what happens before this. We only care about the index that is adjacent to it, right? So obviously the answer would depend, like the answer of this block would depend on what we do here in this block. But at one particular time, we don't need to annoy ourselves with all those details. We can only focus on these two indexes. So what you can do is that suppose currently I am at index I and I'm thinking about the sunny state, then what would it depend on? Like if currently I'm at the sunny state, then if my previous index, like if my previous index is a 0 is a rainy state, right? If it is a rainy state, then I can just add the y value here. So this is one possibility. what is the other possibility? Other possibility is that the previous state is also a sunny state. In that case, sunny followed by sunny won't require a y to help us. So the thing is that dp of I minus I, and you would just make it like, okay, so this would be 0 and my mistake here, this should be 1, right? So, and you won't add anything here. So whatever be the maximum among these two values that you are going to take. Now, the second case is that suppose my current one is rainy. If currently I am at a rainy state, then whatever be the value of the previous index, we are not going to add y. So we'll simply take the maximum of dp of I minus 1 and 0, and then the second would be dp of I minus 1 and 1. So this would be the transitions. Okay. So the transitions are very straightforward in this. Like, you guys can ask if you have any doubt. So these would be the transitions here. And the base case, like the base case would also be very easy to define. You basically just go at the starting index and you would manually define it. And after that, these are the transitions that should fetch you the right answer. So I hope I'm clear here. And so these would be the transitions, but since the question also says that there is a certain X value that you need to subtract if you're swapping. So if currently I'm working with, this is my current state, and suppose my current character is R, but I'm working, but here I'm assuming my current character is S because 0 stands for S, right? So I would just subtract minus is equal to X value here because I'm converting, right? But if I were working with 1, then I wouldn't need to subtract anything. Similarly, you can write for S case also. So that would be exactly same. You would just have to swap 0 and 1's position here. So I hope I'm clear with the explanation. You can stop me anytime. Okay. So basically, this is the implementation that I've explained so far. So the base case is pretty easy to define here. If the starting 0th index is R, then if it's sunny, then you just subtract the value to change it. If it's already rainy, then you don't need to do anything here. Similarly, if the starting index is S, then these are the operations you need to do. And here are our transitions that I explained right now. For sunny, if it's sunny right now, then in the previous rainy case, you would have to add y, else it would just be the maximum of the previous two values. And these are the conversions that you need to perform. And finally, whatever be the maximum of the last index among the both possibilities, that should be your answer. So this was the explanation of this question. If you have any doubts, you're free to ask. Okay, so I'm assuming I was very clear with it. Okay, thank you. Now we'll be moving to the Codeforces discussion.
I hope I am audible and my screen is also visible. Right? Am I audible? And now? Okay, let's start. So, how many questions you solved in the Codeforces Round 1105?
I actually didn't attempt this one. I was at an event. I just attempted the coders chef, that coders one, and left.
Okay, fine. So, okay. So, we'll discuss the problems. So the first problem is related to that. Yes, you are given two things, n and k. Okay. So the question basically says that okay, you have to make an array of k integers, a1, a2, a3 up to ak, such that k is less than equal to n, and total number of this thing, total number of bits in all the numbers a1 to ak is kind of maximized. Okay. Okay, let me explain this with a clear binary representation approach, so it will be clear. Uh, right. Okay. So basically, it says suppose this is A1, A2, A3 dot AK. Okay, and this is my n. Suppose it has a binary representation of let's say 110, 110, and this is my 0th position, 1, 2, and so it will be 4 and 8, 16, and suppose initially all the bits in each number is 0. Okay. Right. Okay. So what we have to do is, okay, we have to make the sum equal to this, less than equal to n, and set some of it bits. Okay. So if I am setting this bit, so if this will become 1, so my a3 currently becomes 8, and if I set this bit of a2, so my currently a2 becomes sorry, it will be 4. My a2 currently becomes 1, and again if I set this bit 1, so my okay, I think I should erase this. This is not needed. Okay, so my currently a2 becomes not 1, 2 plus 1, 3. So in this way I can set any of the bits, and my sum must be less than equal to n. Okay, and another thing given in the question is that okay, my a1, a2, a3 must be non-negative integers. That means they can be 0. Okay, so I can like set any of the bits, but I have to maintain this condition that the sum must be less than equal to n, and I have to maximize the set bits. Okay, I have to somewhat maximize. That is my pop count of AI summation must be maximized. Okay, so how can I do that? Okay, the question comes, how can I do that? You will observe that, okay, whenever I am setting this bit, you will observe that what is the cost of setting this bit? What is the cost of setting this bit? Yeah. Whatever I'm setting this bit, whenever I'm setting this bit, yeah, what is the cost? Oh, right. Whenever I'm setting this bit, the cost is 1. Whenever I'm setting this bit, the cost is 2. Okay. So in order to maximize the number of set bits, what I would do, I would first start from here and set all the ones here. 1, 1, 1. Since this will cost me nothing but 1. Okay, till I get this sum less than equal to 10, what I will do, I'll set all these ones. Then after that, if my n is currently greater than 0, after all this setting 1, okay, so now I start from this. So setting all these ones will have a cost of each equal to 2. Okay, since I have to maximize my number of set bits, so I will start from the left hand since it has the minimum cost. Then then for setting each bit in this column is 4. Okay, so in this way I will have my optimal maximum number of set bits. Okay, so what I would do, I will start from 1, then go to this column 4, 16, and try to set as many bits possible. Okay, in this, and this. Okay, so in this way, I can get my answer. So let's look at the code. Okay, uh, yeah, and now I think let me take a screenshot. Yeah, now it does not happen. That is this one. Okay, so I'm starting from currently zeroth position. That is my 2 to the power 0. So my value is somewhat 2 to the power 0. That is 1. So since I can at most play set k integers, that is a1 to ak. So I'm currently seeing whether it is number of, if it is 1, so I can like set n by 1 numbers. If it is 2, so I can at most set n by 2 numbers. If it is 4, I can set n by 4 numbers. So since I have only k numbers available, I will like take the minimum of k and this n by b, and one left set I is basically 2 to the power I. So okay, so I'll increment my answer, and since I have like set all these ones, so my current n is decreased by q star b. This b is the value, and q is the number of times I've used this thing, and ultimately calculating my answer. Okay, so were you able to understand? Okay, right. Right. Okay, next, go to problem B. So you can read the question. I'll basically tell you that you are given 4 okay, and M R C. So N is matrix of the matrix with n columns and sorry n rows and m columns. So this R comma C is basically a submatrix. So you can take a submatrix of R cross C. So this is my submatrix. So it has R rows and C columns. Okay. So but the question says that whatever, and each matrix is position is either 0 or 1. So whatever you place is, you place 0 here, 1, 1 here, 1, 0 here. My XOR of all these elements, 0, 1, XOR, 1, XOR, 0, must be equal to 0. Okay. And if each submatrix of each R comma C submatrix XOR is equal to 0 of, then I can say that this n cross m matrix is a clean matrix. Okay, is a clean matrix. So I have to find basically the number of such matrices of n cross m, number of n cross m submatrices, sorry matrices, such that such that every R cross C submatrix XOR is equal to 0. Right? So you can like, okay, scans every single submatrix of A consisting of R rows and C columns, and the matrix is clean if bitwise XOR sum of elements in each such submatrix is equal to 0. Okay, so I have to find the number of such matrices and then calculate modulo 998244353, since the answer can be very large. Okay, so let's see how can we do it. Okay, so let me assume the matrix first. This n cross m. before that, tell me one thing. What do you mean by XOR is equal to 0? If it contains elements 0 or 1, can you tell me any observation what you got? Okay. If I have to make my XOR is equal to 0, what condition I can get from 0 and 1? Uh, okay. So basically, the condition is that I must have even number of ones so that my XOR is equal to 0. Okay. This condition must be satisfied since 0 cross 1 and 1 cross 1 XOR 0 is 1, and same 0 XOR 0 and 1 XOR 1 is equal to 0. So to get XOR equal to 0, I must have even number of ones. Okay. Now we will notice one thing is that if in each submatrix I have whatever I place here, here. In this position, I can it have a forced value because if these things have odd number of ones, I must place 1 here, and if this has a even number of ones, so to make the XOR equal to 0, I must have here 0. Okay, so if there are odd number of ones, that position must be occupied with 1, and if there are even number of ones, that position must be occupied with 0. So in each submatrix of R cross C have a first position, and number of such submatrix of uh, R cross C submatrix in N cross M matrix is basically N minus R plus 1 star M minus C plus 1. I can get this formula from, okay, so you can choose any number of ways. It is a number of ways to choose rows of the submatrix, and these are the number of ways to choose columns of the submatrix. So total number of submatrix is basically the number of ways to choose rows and number of ways to choose the columns and their product. So in total, I have total number of these number of forced position. So it will these positions will have a particular value, that is this. Okay, so in this way I can calculate my number of free position. So my free position will be my total available position, that is n star m, minus total number of forced position. So it will be n into m minus n minus r plus 1 star m minus c plus 1. Okay, so I have total number of this free position. So in this free position, I can either place a 0 or a 1. So basically it has two ways. So total number of matrices I can form is basically 2 to the power number of free position. This is my required answer. Okay, then since in this free position I can either place 0 or 1. So each free position contributes to 2, and number of such matrices will be 2 to the power position. Okay, let us look at in these are basically my forced position, and then I would have the remaining, that is free positions, and then you can power it and modulo. This you can use this power function and then modulo the answer. In this way, you can get the required number of div. So in this way, you can solve this thing. And yeah, I hope you are able to understand what I was trying to say. Okay, remaining questions. That's why. Yeah.
Okay, am I audible? Okay, give me a second. I'm not able to share my screen, so let me reconnect. I hope I am audible and my screen is visible also. Okay, so our next question is main game is your game. So in this game, Alice and Bob are playing a game with an array consisting of n non-negative integers, and Alice goes first. And in each turn, the current player must choose an array of non-negative integers b such that it satisfies the following conditions. The conditions are bi must be between ai and 0, and sum of bi must be positive. That is, we should have at least one non-negative element. We should at least have non-zero element, right? So we cannot pick all the elements equal to 0. And XOR of all element of B should be 0. So after picking the array, we have to convert our array A into AI minus BI, changing all elements like this. Now, the player who cannot perform such operations, such as operation loses the game. If there are no moves left, then the game will end and the player will not able to uh, make the next move. He or she will lose the game. Now, determine the number of valid choices for the array of P that Alice can make on her first move to guarantee a win, assuming both players play optimally. Since this number may be large, output the answer modulo this. So let's look on to the question. We have an array. Something is given there. Suppose A, B, C, D. Now, uh, Alice need to make a first move, and in first move she need to choose a array B size of n such that all the elements of B must be uh, like XOR of all elements of the B must be equal to 0, right? And the second condition is suppose this element is R must be less than or equal to A, and this condition holds for each element of this array, right? Now, suppose the array is given. Now Alice need to make the move. So what will be the uh, move by Alice such that the game will left with no moves and the other player will lose. So if we see some of the test cases, suppose I am taking this test case 1-1. Suppose the array A is this only.